Okay, in this video we're going to cover the 6.1 worksheet. In number 1, we're asked to solve for x in the triangle and round to the nearest tenth. In relationship to the 68 degrees, we are given our adjacent, which is our unknown value, and the hypotenuse. So adjacent over hypotenuse, we should use cosine. So I put cosine of 68 degrees is equal to adjacent, which is x, over hypotenuse, which is 10. Multiply 10 to both sides, plug this into the calculator, make sure you're in degree mode, and you should get 3.7. Number 2 says we're going to find the length in a word problem. The kite is 67 feet off the ground, so here's our distance. The string is pulled tight, and the angle of elevation of the kite is 64, so we're using this picture. Find the length of the string. So what we're trying to find is the hypotenuse of this triangle. So given this angle in relationship, we're also given the opposite, and we're looking for the hypotenuse. So we'll be using sine. Sine of 64 is equal to opposite, 97, divided by r. Okay. To solve for r, remember what we're going to do is take these two and just flip it. We'll have r is equal to 97 feet over sine of 64. Make sure your calculator's in degree mode, and you should get 107.9 feet, 1 decimal place. Number 3, we are trying to find the answer to the nearest tenth of a degree, so we're going to be using degrees. We don't know the angle, but we are given the adjacent and the hypotenuse. So that means we should use our cosine. So cosine x is equal to adjacent, which is 9, divided by hypotenuse, which is 19. Remember, in this case, we just need to separate the cosine from the x, so we're going to do the inverse cosine of that ratio. As long as you're in degree mode, you'll get the correct answer of 61.7 degrees. Number 4, we're also going to solve another trig function in a word problem. It says a 16-foot ladder leans against the side of the house. So right here is 16 feet. The bottom of the ladder is 7 feet away from the side of the house, so we're given 7 feet over here. Find x, which is the angle of elevation for the ladder. We're going to round to the nearest tenth of a degree. So here we're finding x, but in relationship we're given our adjacent and our hypotenuse, so we should use cosine. So cosine of x is equal to 7 over 16. The feet cancels out, and then we're going to go ahead and separate the cosine from the x by doing the inverse. So x is equal to the inverse cosine of 7 over 16. Make sure you're in degree, and you should get an answer of 64.1 degrees. Number 5 says solve the right triangle. Anytime it says solve the right triangle, you're going to find for all the missing variables. So in this case, we're labeled here A. Angle B will be here, and this is angle C. So these are the ones that we're given. We're given angle B, and we're given angle C, and we're given little c. So what I'm going to do first is go ahead and solve for the big A. So A is going to be equal to 180 degrees minus of angle B, which is 48 degrees, minus the right angle, which is 90 degrees. You should get 42 degrees for angle A. Next, what I'm going to do is take the 48 degrees, the part that is actually given, and now I'm going to solve for little b. Little b is opposite, and I'm given the hypotenuse, so I want to use sine. Sine of 48 degrees is equal to little b over 14. Multiply each side by 14, and you get b is equal to 14 sine of 48. Make sure you're in degree mode, and you'll get b is equal to 10.4. Since there are no units, you don't have to add units in this problem. Okay? Then we need to find little a. Again, I'm using the 48 degrees because that is given, and I'm going to need to find the adjacent over the hypotenuse, so this time we're using cosine. Cosine of 48 degrees is equal to a over 14. Multiply 14 to both sides of the equations, and you get a is equal to 14 cosine 48 degrees. Again, make sure you're in degree mode, and you get A is equal to 9.4. Okay, number 6. It says, looking up, Dan sees 2 hot air balloons in the sky as shown. He determines that the lower hot air balloon is 810 meters away at an angle of 19 degrees from the vertical. So here is just saying for the vertical, here's 19 degrees, and the hot air balloon is 810 meters. The hot air balloon is 935, that's this one, away at an angle of 15. So there's my 15 right here. How much higher is the balloon on the right? So what we want to do is just find the distance between the 2 air balloons, which is I labeled as x. First thing we're going to do is solve for a. From here to here is going to be our a. If we're given this angle, this would be adjacent, this would be hypotenuse. So I can use cosine. Cosine of 19 degrees is equal to a over hypotenuse, which is 810 meters. Multiply both sides by 810, and I get a is equal to 810 cosine 19 degrees. Make sure you're in degree mode, and you get a is equal to 765.87. It says here round to the nearest 10. All I did here was store this exact value into a. The second thing I'm going to do is solve for the distance of the bigger triangle. Now here you have to realize that the distance of the bigger triangle on the vertical side is a plus x. So that's what I did here. I'm going to solve for this entire distance. I'm going to again use cosine because I have the adjacent variables that I'm looking for, and I'm given the hypotenuse. So here it'll be cosine 15 degrees is equal to adjacent, that's x plus a, divided by 935 meters. Here I'm going to multiply both sides by 935, and I get x plus a equals 935 meters cosine 15 degrees. Okay, x plus a comes out to this number. A is the variable that I stored into this. So I'm going to go ahead and show you how I did this in the calculator so it makes more sense. I'm going to start with 810 cosine of 19. Okay, here's that number that I got, and all I'm going to do is store to the variable a. Okay, now it's in the calculator. So when I come down here and I'm looking for this value, I'm going to go ahead and clear this out, and I'm going to do that in the calculator. 935 cosine 15. That is this value. In order to solve for x, I'm going to subtract whatever is in my a. So from here, I can go minus, and I'm going to recall. Now, recall will be second store, and then I'm going to recall the variable that I originally put in a, and then I'm going to get x is equal to 137.3. The 7 rounds to the 2 going up, and we were trying to find to the nearest tenth. Okay, I do this because then I know that I will get the exact rounding correct, and you won't have any rounding issues. Because if you just stop here and here, let's say you use the 1 and you use the 8, you may not necessarily get the 3 when you subtract them. Okay, so be careful. Okay, that actually concludes 6.1 worksheet.